A dwarf planet 4 billion miles away is running its own private refrigerator, cooling itself down using nothing but the haze in its own sky. And nobody expected a world that small and that cold to be doing anything like this. Stick around, because I'm about to walk you through what scientists actually just confirmed about Pluto, and hit subscribe now, because this channel breaks down real space discoveries without the exaggeration. And you do not want to miss what else is coming out of the outer solar system. Let's go back to where this story actually begins, because Pluto's history is stranger than most people remember. In 1930, a 24-year-old assistant named Clyde Tombaugh, working at an observatory outside Flagstaff, Arizona, was given one of the most tedious jobs imaginable. He photographed the same patch of night sky on different nights, then flipped back and forth between the plates, searching for a single point of light that had shifted position. Most nights produced nothing at all. Then, on one plate in February of that year, something moved. A tiny dot had shifted against a background of fixed stars, and that dot became Pluto. For the better part of a century afterward, it held the title of the 9th planet in our solar system, even though it was so distant and so small that astronomers could only guess at what it actually looked like up close. Then, in 2006, the International Astronomical Union held a vote and formally reclassified Pluto as a dwarf planet, stripping it of the title that had made it famous. It remains the only world in recorded astronomical history to be discovered, celebrated, and then formally voted out of the very category that once defined it. For a long time, that felt like the end of the story. Pluto was small, distant, and easy to file away as unimportant. That assumption did not survive contact with real data. It is worth pausing on just how little we actually knew about Pluto before any spacecraft ever visited it. For most of the 20th century, even the largest telescopes on Earth could only resolve Pluto as a tiny, blurry smudge of light. Astronomers could estimate its orbit fairly precisely, since that only required tracking its position over time, but its size, its surface composition, and whether it even had an atmosphere at all remained genuinely open questions for decades. Some early estimates wildly overstated its size, assuming it needed to be large enough to explain certain gravitational effects on the orbits of Neptune and Uranus that were later found to be measurement errors, rather than real influences from Pluto at all. In other words, much of what the public believed about Pluto for generations was built on guesswork stacked on top of more guesswork, which makes what happened next even more remarkable. In July of 2015, after a journey lasting 9.5 years across billions of miles of empty space, NASA's New Horizons spacecraft flew past Pluto at more than 30,000 miles per hour. It had exactly one chance. No orbit, no second pass. Just a narrow window of a few minutes to capture as much as it possibly could before continuing on into the darkness of the Kuiper Belt forever. What it sent back completely rewired what scientists thought they knew. A massive, pale, heart-shaped plane stretched across the surface, smooth and strangely young-looking compared to the ancient, heavily cratered terrain surrounding it. Mountains built from solid water ice rose more than 10,000 feet into a thin, hazy sky, frozen so hard at those temperatures that it behaved less like ice and more like solid rock. Fields of nitrogen ice appeared to be slowly churning in giant convection patterns, hinting at heat and motion happening beneath a crust that scientists had assumed was completely dead. And layer after layer of blue haze rose hundreds of miles above the surface, visible even when backlit by the sun. Pluto did not look like a leftover chunk of frozen rock. It looked like a world still in the process of becoming something. But New Horizons only got one look. It captured what it captured, and kept flying deeper into the outer solar system, never to return. Whatever it missed on that single pass would remain a mystery for years, while scientists argued over the data and built models they had no real way to test. What researchers needed was not a better photograph. They needed a way to read Pluto's chemistry directly, from millions of miles away, without ever sending another spacecraft. That is exactly what the James Webb Space Telescope was eventually able to do. Here's what makes Webb fundamentally different from a spacecraft like New Horizons. Webb does not fly past anything and snap a picture. Instead, it reads light itself, breaking it apart into its individual wavelengths to reveal the precise chemical fingerprint of whatever it happens to be staring at. Pointed at a faint pinprick of reflected sunlight billions of miles away, it can tell researchers what molecules are present, how warm different layers of an atmosphere actually are, and how that atmosphere is behaving over time, all without physically traveling anywhere. The technical challenge involved here is worth appreciating on its own. Pluto and Charon sit so close together in the sky, from Webb's point of view, that separating their individual thermal signals used to be practically impossible with earlier generations of telescopes. Researchers working before Webb launched had repeatedly tried to detect this exact haze signature and repeatedly came up empty. Not because the signal did not exist, but because their instruments simply could not tell how much of the detected heat was coming from Pluto itself and how much was bleeding in from Charon sitting nearby. Webb's much larger mirror and far more sensitive infrared instruments finally solved that specific problem, allowing scientists to cleanly isolate Pluto's own thermal signature for the first time. Starting in 2022, once its instruments were fully calibrated and capable of separating Pluto's faint signal from that of its large neighboring moon, Webb turned its attention toward Pluto. And what has come back over the years since has not simply been a prettier picture. It has been closer to a full diagnosis, revealing a set of behaviors so unusual that researchers are still working out exactly how to explain some of them. If you are the kind of person who wants space stories explained clearly instead of buried under jargon, go ahead and drop a like on this video right now, because it genuinely helps this kind of content reach more people who would enjoy it. The first major finding involves that same blue haze, New Horizons, first photographed back in 2015. Researchers already knew Pluto's thin atmosphere was wrapped in a delicate shroud of hydrocarbon particles, but what nobody had confirmed was exactly what that haze was doing to the world underneath it. Back in 2017, a planetary scientist named Xi Zhang, working at the University of California, Santa Cruz, proposed an idea that sounded almost backwards at the time. On Saturn's moon Titan, atmospheric haze traps heat and warms the world below it. Zhang argued that Pluto's haze might be doing the exact opposite, absorbing sunlight during the day and then radiating that energy straight back out into space as infrared heat, faster than Pluto's extremely thin atmosphere could ever hold onto it. In effect, the haze would not be acting like a blanket. It would be acting like a radiator, actively bleeding heat away from a world that already had almost none to spare. At the time, this idea struck many of Zhang's peers as unlikely, and there was no instrument available yet capable of actually testing it. That changed once Webb's mid-infrared instrument became available and sensitive enough to separate Pluto's faint thermal signal from that of its largest moon, Charon, something earlier telescopes had never been able to do cleanly. A team of researchers led by astronomer Tanguy Bertrand at the Paris Observatory used that instrument to measure Pluto's atmosphere directly, and the results, published in the journal Nature Astronomy in June of 2025, confirmed almost exactly what Zhang had predicted 8 years earlier. Pluto's upper atmosphere really is being actively cooled by the very haze particles suspended within it, and it turned out to be roughly 30 degrees Fahrenheit, colder than earlier models had expected. Researchers now describe this as a genuinely new kind of climate, one that behaves differently from every other atmosphere we have studied anywhere else in the solar system. Pluto is not simply cold because it sits so far from the sun. In a very real sense, Pluto appears to be actively refrigerating itself. And scientists are still working out how far the consequences of that discovery actually reach, including whether similar hazes might be quietly shaping the climates of other distant hazy worlds like Neptune's moon Triton, or even hinting at what Earth's own atmosphere may have looked like billions of years ago, long before oxygen ever built up in our skies. There's a second discovery tied to that same haze, and it is quieter, but honestly just as strange once you sit with it. Even the extremely faint trickle of sunlight that reaches Pluto is enough to break apart methane molecules high up in its atmosphere. Those broken fragments do not simply vanish, they recombine into heavier compounds, forming a slow chemical cascade that eventually produces reddish-brown particles known as tholins, which drift downward and settle onto the surface below. New Horizons caught early traces of this chemical process back in 2015, and more recent observations have continued to refine exactly how it unfolds. Here is the detail that tends to stop people in their tracks. Tholins belong to the same broad family of organic molecules that some scientists believe may have once rained down onto early Earth, potentially contributing raw material for the kind of chemistry that eventually led to life here. On Pluto, that same basic process has apparently been running for roughly 4 billion years. A slow, continuous snowfall of biological building blocks, landing on a surface that is simply too frozen for any of it to ever spark into something alive. To really understand how extreme that cold actually is, it helps to look at the raw numbers. Sunlight reaching Pluto is roughly 1,000 times fainter than sunlight reaching Earth, meaning even high noon there would look closer to a heavy twilight here. Surface temperatures generally sit somewhere between about negative 387 and negative 369 degrees Fahrenheit, more than 250 degrees colder than the coldest temperature ever recorded anywhere on Earth. At those kinds of temperatures, nitrogen, the same gas that makes up most of the air you're breathing in right now, freezes completely solid. The atmosphere you're standing in as you watch this video would, on Pluto, simply become part of the frozen landscape. It is worth explaining a little more about why researchers care so much about this particular chemical process, beyond simply finding it strange. Scientists studying the origins of life on Earth have long debated where the first organic building blocks actually came from, whether they formed here on the early planet itself, or whether at least some of that raw material arrived from space, carried in by comets, asteroids, or slow chemical processes happening in distant, icy environments similar to what we now see happening on Pluto. Studying a real, ongoing example of that chemistry, running continuously for billions of years on a nearby world, gives researchers something they otherwise could never have: an active natural laboratory for a process that on Earth finished playing out and left behind only indirect evidence billions of years ago. Pluto, in that sense, is not just a curiosity. It may be one of the closest things we have to a working model of the raw chemical conditions that existed before life ever began anywhere. The third major finding is the one that tends to unsettle people the most once they hear it explained properly. Pluto has been slowly leaking into space for billions of years. Methane and other light molecules drift upward through its thin atmosphere, slip past its weak gravity, and escape outward. Scientists already suspected this was happening, but for a long time, nobody knew exactly where all of that escaping material was actually going. It was not simply vanishing into empty space. Something was catching it. Pluto's largest companion, a battered ice moon named Charon, roughly 750 miles across, orbits in an extremely tight gravitational partnership with Pluto. Most of Charon's surface is fairly unremarkable water ice, ancient and heavily cratered, except at its poles, which are stained a deep, unmistakable reddish-brown, darker than anything else visible on the moon. For years, researchers suspected a connection between that coloring and material escaping from Pluto, but they lacked the tools to confirm it directly. The mechanism behind this turns out to be tied closely to Charon's extremely slow, extremely long seasons. Because of the way Charon is tilted as it orbits alongside Pluto, its northern polar region spends multiple decades in complete darkness at a time, with no sunlight reaching it at all during that stretch. That makes the pole an extremely effective cold trap, a place where escaping methane molecules drift in, freeze solid onto the surface, simply because there is no warmth to keep them as gas, and then sit there accumulating for years before sunlight finally returns to that part of the moon. Once sunlight does return, it does not simply melt that frozen methane away. Instead, ultraviolet radiation and cosmic rays break the frozen molecules apart and reassemble the fragments into heavier, more complex reddish compounds, essentially locking in that dark coloring permanently rather than letting it evaporate back into space. Earlier research, including a widely cited 2016 study, showed that methane escaping from Pluto's atmosphere drifts across the roughly 12,000 miles of space separating the two worlds, gets captured by Charon's gravity, freezes onto its cold polar surface, and is then broken apart by sunlight and cosmic radiation into the same kind of heavy organic compounds that color Pluto's own surface. In effect, two worlds locked together in a slow, ongoing exchange of atmosphere and color that has apparently been running quietly since long before either one had a name. Charon had one more surprise waiting too. In October of 2024, a team led by researcher Silvia Protopapa at the Southwest Research Institute used Webb data to confirm the presence of both carbon dioxide, the same gas leaving your lungs with every breath, and hydrogen peroxide, the same compound sometimes used to disinfect a wound, frozen directly onto Charon's surface. According to the published research, the carbon dioxide most likely originated from underground material exposed by impact craters, while the hydrogen peroxide appears to have formed through years of radiation striking Charon's water ice and rearranging it into something new. Researchers noted that this specific combination of frozen chemicals had never been confirmed on Charon before, adding yet another layer to a moon that keeps turning out to be far more chemically complex than its plain, icy appearance would ever suggest. If you have found this as strange and fascinating as I did while researching it, drop a comment letting me know, because it genuinely helps me figure out what other space stories are worth covering next. Now picture, for just a moment, what it would actually be like to stand on Pluto's surface, because the details are almost hard to imagine otherwise. The sun would still be visible, but only as an intensely bright point of light, smaller than a pinhead held at arm's length, giving off no real warmth and no meaningful glare. You could look directly at it without any discomfort at all. The sky around it would sit in a permanent grayish-blue gloom, thick with haze, never fully day and never fully night, just an unchanging dimness. The ground beneath your feet would not behave anything like ice does here on Earth. At nearly 400 degrees below zero, water ice stops being slippery and instead behaves closer to solid rock, hard enough to ring almost like metal if struck. The atmosphere, roughly 100,000 times thinner than Earth's, would offer nothing to breathe, though the extreme cold would reach you and freeze exposed skin almost instantly, long before the thin atmosphere itself became the immediate danger. And overhead, fixed permanently in the same spot in the sky, Charon would hang there, unmoving. The two worlds are close enough in size that they do not orbit each other the way Earth orbits its own moon. Instead, they orbit a shared point in empty space between them, locked so tightly that each one always shows exactly the same face to the other, a silent standoff that has been running for billions of years. The surface itself holds its own separate mysteries. In a region researchers named Tartarus Dorsa, New Horizons photographed something no spacecraft had ever documented anywhere else in the solar system. tall rows of jagged ice blades, some reaching more than 1,500 feet high, made of frozen methane and arranged in long parallel ridges. Similar but far smaller formations exist here on Earth in certain high-altitude deserts, where they are known as penitentes and rarely grow taller than an average person. Scientists believe these Earth-based versions form through a slow process where sunlight causes uneven melting and sublimation across an icy surface, carving out taller sections while lower areas erode away faster, gradually sculpting the ice into narrow blade-like ridges over time. On Pluto, that same basic process appears to have played out on a vastly larger scale, over a much longer stretch of time, and using frozen methane instead of frozen water. A 2025 analysis of the original New Horizons data suggests these towering ice blades may wrap around as much as 60% of Pluto's equator, forming an entire ring of jagged frozen terrain circling the dwarf planet. Elsewhere, a massive dark region roughly the size of Alaska stretches across the equator, colored a deep reddish-black, where those falling organic tholin particles have apparently piled up thickest over billions of years on some of the oldest and most exposed terrain anywhere on the planet. South of that famous, pale, heart-shaped plain, two enormous, isolated peaks rise out of the surrounding landscape, and researchers still cannot fully explain them. One stands roughly 13,000 feet tall. The other may reach close to 20,000 feet, with a base wide enough to rival some of the largest volcanoes here on Earth. Both mountains have deep depressions at their summits, ringed by fractures, with lumpy uneven flanks that closely resemble cooled lava flows. Except, of course, there is no molten rock on Pluto. If these features are what they appear to be, they are cryovolcanoes, structures that once erupted not with melted stone, but with a thick slurry of water, ammonia, and methane forced upward from somewhere deep beneath the icy crust. Researchers remain divided on exactly how these particular formations came to exist, whether from a handful of massive eruptions or many smaller events spread across a longer stretch of time. Either interpretation points toward the same unsettling conclusion that something, at some point in Pluto's relatively recent geological history, was warm enough beneath that frozen shell to force liquid material all the way up to the surface. That internal warmth leads directly to one of the most debated ideas surrounding Pluto today: the possibility of a hidden ocean buried roughly 100 miles beneath the surface, kept in a liquid state by the slow radioactive decay of elements inside Pluto's rocky core. The evidence for this is not a photograph, it is a pattern. Cracks and ridges across the surface line up in ways that fit what you would expect from a subsurface layer of liquid water shifting slowly beneath the crust. And that famous pale heart-shaped plane sits directly above what appears to be a positive gravity anomaly, a spot where something denser than the surrounding ice may be concentrated underneath. It is worth explaining why scientists find a buried ocean scenario like this so genuinely compelling, even without direct proof. Similar hidden oceans are already strongly suspected beneath the icy surfaces of Europa, one of Jupiter's large moons, and Enceladus, one of Saturn's smaller moons, both of which show far more obvious surface evidence, including geysers of water vapor erupting directly into space in Enceladus's case. If a body as small and as cold as Pluto turns out to be hiding something similar, it would suggest that buried oceans might be a far more common feature of icy worlds throughout the outer solar system than scientists previously assumed, rather than a rare exception limited to a handful of larger, more actively studied moons closer to the Sun. If that ocean genuinely exists, it has likely been there for billions of years, sealed away completely from sunlight and radiation, fed only occasionally by hydrocarbons seeping downward through cracks in the ice above it, sitting under enormous pressure in total isolation. It would represent one of the strangest possible environments in the entire solar system for the basic conditions life requires, existing without any direct connection to a star at all. Right now, there is no way to confirm any of this directly. There is currently no funded mission planning to send a probe back to Pluto, no lander, no orbiter on the books, largely because the journey alone would take the better part of a decade, and outer solar system exploration has rarely been treated as a funding priority. It is worth understanding briefly why that is the case, because it is not simply a matter of scientific interest. Missions to the outer solar system are extraordinarily expensive and extraordinarily slow, often requiring a full decade or more of travel time before a spacecraft even reaches its target, followed by a single brief window to gather data, much like New Horizons experienced. Space agencies generally have to weigh a mission like that against many other competing priorities, including missions closer to home that can return results within just a few years instead of a few decades. That trade-off means distant, icy worlds, like Pluto, often lose out in funding decisions, not because scientists have stopped finding them interesting, but simply because the practical cost and timeline involved make them a much harder sell compared to closer, faster missions. For the time being, Webb remains our only working tool, quietly checking back in every few months whenever Pluto swings back into its field of view, adding another data point each time, and almost always making the overall picture stranger than it was before. Here's the detail that tends to stick with people longest after they hear this whole story. Pluto is not unique simply because of its location. It sits inside the Kuiper Belt, a vast ring of icy debris beyond the orbit of Neptune, home to hundreds of thousands of objects wider than 60 miles, along with an estimated trillion or more comets. A handful of other bodies out there, including Eris and Makemake, come reasonably close to Pluto's size. Beyond the Kuiper Belt entirely lies the theorized Oort cloud, thought to hold another trillion or so icy bodies, stretching outward roughly a quarter of the way toward the nearest star. To put the scale of that region into perspective, the Kuiper Belt alone is estimated to span an area of space hundreds of times larger than the much more familiar asteroid belt sitting between Mars and Jupiter, the one most people picture when they think of a field of space rocks. And unlike that inner asteroid belt, which has been mapped in fairly close detail thanks to its relative proximity to Earth, the Kuiper Belt remains almost entirely unexplored territory. Only one spacecraft, New Horizons, has ever ventured deep enough into that region to closely photograph any of its larger residents, and even that mission only managed close flybys of two objects, Pluto and a much smaller, more distant body nicknamed Arrokoth, out of the hundreds of thousands of similarly sized worlds believed to exist out there. If Pluto is genuinely cooling its own sky, slowly bleeding its atmosphere onto a companion moon, and possibly hiding a liquid ocean beneath a shell of solid ice, there is no obvious reason to assume it is the only object out there doing anything like this. It is simply the one close enough and bright enough for our current instruments to study in real detail. Nearly everything else scattered across that same enormous region of space, an area hundreds of times larger than the asteroid belt, remains almost entirely unobserved. So what does all of this actually add up to? Pluto was never really the dead end of the solar system that a single vote in 2006 made it seem like. It turned out to be the beginning of a whole set of new questions that scientists are still learning how to properly ask. Out past the orbit of Neptune in the cold and the dark, there are trillions of other worlds we have barely glanced at, let alone studied closely. And if one small, frozen, formerly dismissed dwarf planet was hiding this much complexity underneath its surface, it is genuinely worth wondering what all of those other distant worlds might be hiding too. If stories like this one, grounded in real, published research rather than exaggerated headlines, are what you want more of, subscribe to this channel and turn on notifications, because Webb is still pointing back at Pluto every few months, and there's a real chance the next round of data adds another genuinely strange piece to this puzzle. Thanks for watching, and I will see you in the next one.